Hi guys, let me quickly demonstrate or show you um, what I was saying about the multicast addresses. For an interface to be able to participate or be represented by a particular multicast address, it needs to join that address group. This is done automatically, and it depends on what the configuration is. For example, what the interface's configuration is. For example, let's say, for example, that we enable IPv6 on the interface. As you know, one of the things that will happen, or the first thing that will happen, will be in a link local address will be assigned to it. However, there are another thing that happens when we do that. Um, the interface gets automatically joined into three different multicast address groups. One of them is the all nodes address multicast address group, which is FF02 colon 1, and also the all routers multicast address group, which is the FF02 colon 2. There's a third multicast address that the interface gets joined into, which is the solicited node multicast address group. We're going to talk about that third option a little bit later. Let me go ahead and demonstrate that, what I just said. Let's go ahead and do get into global configuration. Let's get under the interface. One more time, this is my live router providing access to my house. I do not touch the real quote unquote real interfaces. I just created a loopback interface. Do show IPv6 interface brief. As you can see, there are no IPv6 addresses configured on any of the interfaces. Also, there's no IPv6 addresses configured in the loopback interface we just created. Let's go ahead and just enable IPv6 on this interface. And again, as you already know, a link local address will be assigned to it, and also the interface will be joined into three different multicast addresses that I just mentioned a minute ago. Let's go ahead and do that. Now let's do a do show IPv6 interface, loopback 1. And here we have the link local address, and also it says join group addresses ff02 colon 1. Again, that is all nodes multicast address. The ff02 colon 2, that is the all routers multicast address. And this is the solicited node address, which we're going to talk about later. Basically, that's it. Depending on the configuration that we use, let me show you what I mean by depending on the configuration. Like I said, all we did right now is enable IPv6 on the interface, and the address got assigned a the interface got assigned a link local address, and it also joined three different groups. Let's say, for example, that we enable a routing protocol on this interface. Let's say RIP, that is easier. Well, it's not easier; it's almost the same, but let's enable RIP on it. And see what happens. I'm going to tell you what happens, and then I'm going to show you. The interface will be joined on this group as is, that was already done, as we just saw, and now it will be joined into another group. That is the multicast address group for the RIP protocol, for the protocol RIP, which is FF02 colon 9, I believe. Let's go ahead and do that. IPv6 RIP. Yeah. Now we need to enter a word to represent it. RIP enable enter. Oh, I'm sorry. We need to enable IPv6 routing on the router itself before we do that. And to do that, we say IPv6 unicast routing. Now IPv6 routing is enabled. Let's go ahead and get into the interface, and again, let's repeat the command IPv6 RIP enable. Okay, we just enabled RIP on this interface. Let's go ahead and do a show command. Let's do show. Here we go. Do show IPv6 interface loopback 1. And as you can see, there's a fourth group now, FF02 colon 9. That's what I mean when I say depending on the configuration of the interface. Before we just enabled IPv6 and joined three different groups. Now we also enabled a routing protocol on the interface, in this case RIP, and the address was also joined um, into this RIP multicast address group as well. If we would have enabled OSPF, there will be another address group assigned, another multicast address group assigned to it. I hope you understood. Thank you very much for watching.